I'm so pleased to be speaking with Dr. Tim Mousseau. He's actually in Kiev right now. He's an evolutionary biologist who works on the effects of radiation on insects, animals, flora and fauna, and he's beginning to look at humans as well. So welcome, Dr. Mousseau. I'm so glad you could join us today. I understand you're in Kiev. Where are you coming from?
Well, we've just spent the last week or so in Chernobyl, actually, doing some studies of mammals in the wintertime. Winter offers some great opportunities to look at how the mammals are doing without the leaves on the trees to hide them.
I bet. It must be pretty cold. There are a lot of snow?
Not as much as we'd like. We'd actually like there to be a lot more snow, and so that we can track the animals through the snow. That's been, global warming has been reducing the length of the winter here as well as many other places. So, unfortunately, not much snow.
And so you work both in Chernobyl and Fukushima. You work in both places. Can you just talk a little bit about that? Share with us why you work. I mean, obviously Fukushima had the nuclear plant meltdowns, but those are your two main research locations?
Yeah, so we've been working in Chernobyl, here in Ukraine mostly, and also in Belarus for 16 years now, actually. And so when the Fukushima accident occurred, we realized we really had to get over there so that we could actually repeat a number of the studies that we've done in Chernobyl in the Fukushima setting to determine whether we're seeing the same sorts of consequences in Fukushima as in Chernobyl. If we found the same kind of responses, that would provide very strong support for the hypothesis that radiation is responsible for the patterns that we're seeing in the plants and animals we've been observing.
So tell us about some of the things that you are seeing. I know I read a bit for an article that I wrote about the impacts on female insects and animals and the radiation and a quicker die-off, but I know you're doing many, many things. So tell us about some of the exciting work that you're doing.
Sure. So we've been, we're evolutionary biologists, evolutionary ecologists primarily by training.
Right.
And so, we've been really interested in how individual fitness is affected, that by that I mean survival and reproduction, how different populations are doing, are populations increasing or decreasing, and how is the overall community being affected by the radiation. And what we found is that we see lots of genetic damage as a result of the radiation. We see that the genetic damage is causing all sorts of phenotypic consequences, so shorter lifespans, sterility in males in many cases, reduced fertility in females as well, tumors, patches of white feathers and different colors, strange colors. But basically the cataracts in the eyes, smaller brains in many of the birds and the mammals. So all sorts of different consequences. Many of them you would predict from the classical radiation studies based on atomic bomb survivors, for instance, or laboratory studies of radiation. And we're just now starting to get into some of the fundamental results from Fukushima 5 years later. We published a new study about, I guess, a month and a half ago, 2 months ago, where we actually reconstructed the doses for about 7,000 birds that we've been observing across Fukushima Prefecture. And using the reconstructed dose, we found a very strong relationship between the abundance and the dose, indicating that just as we'd found in Chernobyl, the radiation was leading to much smaller population sizes for many of the species that live in these areas.
So right now, could you describe, I don't know if you saw my piece in Ms. Magazine, but I quoted you extensively. Can you describe what you're seeing in terms of gender issues and female die-off in the birds and insects?
Yeah, so again, so we have some direct measurements for some species of birds, the barn swallows in particular, where we've actually been tracking individual birds throughout their lives. Mostly in Chernobyl, but we're starting to do this in Fukushima as well. And yeah, the females have dramatically shorter lifespans than the males under these conditions of high radiation. We're seeing actually evidence that many of the other species are affected in a similar way. Again, we can use sex ratios in the populations in different regions to infer what the effects of radiation are on these other species. We just published a paper this week, actually, or last week, sorry, that came out that was related to cataracts in the eyes of small rodents in Chernobyl, and again the females were much more likely to show a cataract in the eye in response to radiation than the males. So there's all sorts of sexual dimorphism, as they say, in response to the radiation effects. And we think this has a lot to do with the fact that, the cost of reproduction is generally much higher for females than for males. And this really, especially for birds and mammals, where, females do most of the work in terms of producing the eggs and caring for the offspring. That's not a universal truth. There are exceptions. There are many species of fish, for instance, where the males care for the offspring. But in general, it's the female that does most of the work. And this exerts an extra cost to the female, physiological cost in terms of antioxidants, and lowers her ability to protect herself from the radiation effects.
And so are you seeing anything with younger animals? Of course, I'm concerned about children, but I know your work is mostly in animals at this point, but are you seeing anything with age-related issues in radiation?
We see big effects on fertility. We can start with day zero. Big effects on sperm, for instance,
Right.
in many of the males. And then, the evidence that we have so far suggests that most of the mortality occurs in that first year class in these organisms, to the extent that we can get that resolution. Certainly points to juveniles being the most sensitive. Clearly, past studies of radiation effects in atomic bomb survivors and other kinds of cancer studies, indicate that in utero exposure to radiation is the most damaging, and so the younger the individual is, the more susceptible they are to the harmful effects of radiation. I think that's pretty much a general rule.
Right, that's the Alice Stewart study that came out in the 1950s that showed that was the first one, the impact of the X-rays, that children were twice as likely to develop cancer who had received one X-ray in the womb. Can you also talk about what you're doing with humans? Because this is an exciting and important field.
Yeah, so I'm not a medical doctor, and so I've been collaborating with a number of medical folks to look at the impacts of radiation on children living here in Ukraine. We've published a number of studies actually showing impacts on various aspects of the blood. Interestingly enough, there was a recent study a couple years ago from Fukushima monkeys that showed parallel patterns of consequences to white blood cells in particular, parallel to what we'd actually documented for children living in radioactive parts of northern Ukraine. And so that was kind of an interesting parallel. We've also been looking at, we're starting to look at genetic effects, direct mutational effects, again, using families of people where one of the parents was exposed to high levels of radiation, either as a liquidator or as a child living in Pripyat during the accident in Chernobyl. And unfortunately, we don't have the results from that yet. But if you call me back in 6 months, hopefully we'll have an answer for you.
And I will do that. So if you were going to sort of send a message to us about why we should be concerned, or are you concerned about nuclear power plants? People say they're innocuous, it's the peaceful atom, we need them for climate change. This is part of the discussion right now, and I'm concerned, as a parent, with Fukushima and the 3 meltdowns there and other nuclear power plants around the world which are aging. Are you concerned about this and what it means to the future of animals, humans, plant life?
Yeah, clearly there are many risks associated with most technologies. The nuclear technology is not immune from such risks as well. I think we're starting to get a better idea of what the actual risks are, especially following Fukushima, and we need to factor that into any equation that deals with our the use of various types of energy. It's really very clear that nuclear accidents, small and large, are more frequent than we had predicted they would be in the past, and that's just that is a big concern. But we're our interests really are in providing the information, the evidence that's needed for accurate policy with respect to energy, and and that information really just hasn't been available until very recently. It's really just been ignored for the most part.
And why is that? Why are there so few studies? You're one of the few people I know doing this kind of work.
Yeah, well, I guess, a lot of it stems from the position by regulatory agencies and intergovernmental agencies that Chernobyl was a unique event, 3 Mile Island was a unique event, and that, these kinds of things would never happen again. But of course, Fukushima has changed everybody's beliefs on that. And so, but prior to Fukushima, there wasn't that much concern about a catastrophic accident of that magnitude, and so there was very little investment in the basic research that's needed to get at these hazards or quantifying these hazards, and so hopefully we're hoping that this will change. We haven't seen many indications that there's increased investment, but I think that it's coming in the near future, hopefully.
And so could you comment, or would you have something to say about the tritium leak that just happened right now outside of New York City at Indian Point Power Plant?
Yeah,
Major leak there.
So, 5 years ago, I was called to serve on a National Academy of Sciences panel following a leak at the power plant up in Vermont, and the Congress wanted to know what the actual hazard would be associated with that leak, and the panel concluded that we really didn't know, simply because there hadn't been much in the way of basic research on the effects of tritium in the environment, and so that was a big unknown, and of course, soon after the Vermont Yankee incident, they started measuring tritium around all of the nuclear power plants around the U.S. and found that more than half of them were actually leaking unregulated amounts of tritium. So this isn't new. This is actually ongoing. I think that perhaps the magnitude of the leak is increased in this particular incident. But to be honest, we probably don't have the monitoring in place to really say for sure whether this isn't or is happening in the other nuclear power plants around the country.
And can you comment on I know there's high leukemia incidence in Europe they're finding and studies there. Could you comment on any of those?
Yeah, so, one of the difficulties of human epidemiology, especially cancer epidemiology, is that you often don't have the sample size, the population sizes, to really do good, robust statistics for diseases that are extremely rare. But yeah, a couple of years ago, Ian Fairley actually put together a meta-analysis of all of the epidemiological studies that have been conducted in Europe related to childhood leukemia around nuclear power plants, and I think his analyses are quite robust. I think they show fairly conclusively that there is definitely an increased risk of childhood leukemia around these power plants, and this really needs to be followed up, I think.
Thank you so much for that. So again, as a parent, I'm always concerned with these issues. Do you think that this is policy that the U.S. should be paying attention to in considering where families live, proximity to nuclear power plants, and that sort of thing?
Yeah, well, luckily, most nuclear power plants perhaps are not embedded within high density population areas as they can be in Europe in some places. But the truth is, where I live in South Carolina, there are quite a number of reactors within less than an hour's drive from where I live, and so we certainly do need to be monitoring these power plants for emissions, especially the unregulated, unmeasured emissions or previously unmeasured emissions, just so that we have a better idea of what the potential hazards really are.
Right. And any last comments on the fish issue and eating? So you're looking at plant life. Are we harmed when we eat plants, for instance, from Japan, or fish from the sea that might be contaminated with radiation?
Well, certainly you don't want to be eating contaminated food of any sort, and this is really a great concern. There are certain food products that are more likely to be contaminated than others, and certainly one should be paying attention to the source of these foods. Radiation is just one of many potential contaminants
True.
in our food source, and so food
Right.
security is a major concern all
Right.
around.
Well, I thank you. Any final words to our listeners if they want to read more about these issues? Your work is, they can look it up in a library database. But any places you could point us to in terms of the general public? I mean, you're writing really for other scientists and biologists and radiation experts. But there might be any books you point us to that the general public could read.
Certainly there was a nice children's book by Rebecca Johnson that was published last year that dealing with Chernobyl that's worth a read. Children and adults. It's extremely well written. There's a number of articles in Scientific American, including one on our Fukushima research related to these kinds of effects. And of course, if people go to my website at the University of South Carolina, if they just type radiation, Fukushima, birds, Chernobyl, they'll find it. And we have links to a lot of the popular coverage of our research, as well as our scientific reports. And certainly people are welcome to peruse that list and contact me directly if there's any questions they might have.
Well, thank you so much. That's really helpful. I know as a listener or a TV watcher, when I hear an expert talking, I want to be able to go find out more. So thank you for that. And so Tim Mousseau it's your website at your University of South Carolina. I recommend to our viewers that you go and read up, because that's how I found him. And actually, I heard you speak at a conference and was really deeply impressed and moved by the information that I learned. So I want to thank you so much for speaking with us today, Dr. Mousseau, and your research is truly fascinating. I look forward to reading more, and I will keep following you closely. Thanks a lot, and talk to you soon. And great, and pass our video along to others. This is really important information that we're sharing.
Well, thanks for inviting me on your show today. Really appreciate it.
Thank you so much.